us look now at hyperbolas which has both the p and the q unequal to 0. So it will result in a vertical as well as a horizontal shift. So p is not 0 and q is in this case positive in this example. Let us just recap again about our mother graph. On this graph you will see it's a broken line. I've just drawn the mother graph so that you can see the relationship between the graphs. So first look at the algebra or the theory, what we need to know. For y equal to 1 over x, the domain is everything except 0 because we cannot divide by 0. And the range is also everything except 0, and the reason for that is the numerator of that function is unequal to 0, so we cannot have an answer of 0. So the x's cannot be 0 and the y's can also not be 0. So that result in vertical asymptote x equal to 0, which is the y-axis, and y equal to 0, which is the x-axis. The lines of symmetry is just plus x and minus x, and it doesn't matter in which order you give it, as long as you remember that we have two axes of symmetry. Get this graph h of x, which is 1 over x plus 1 minus 2, we have to first shift this graph 1 unit to the left because our p-value is -1, which is less than 0. So shift it 1 unit to the left because of the p-value. And then shift it 2 units down because our q is also negative, and to see that it's p equal to -1, I can rewrite this x plus 1 as x minus -1. Remember, our formula is x minus p. Good, so now if I look at my h of x, then my domain is everything except -1. So we exclude the p-value, and everything except -2, so we exclude the q-value. So the vertical asymptote is x equal to -1, and the horizontal asymptote is y equal to -2. This is where x minus p is equal to 0. So in this case we have x plus 1 equal to 0. This is where it will happen. Horizontal asymptote, this is where my q value of y is equal to q. My lines of symmetry, in the place of the x, remember we had y equal to x and y equal to -x. So in the place of x, I will put everything here. I will put what's below here, the x minus p. There it is. One time with a plus sign and one time with a negative sign. Plus and minus, and then I just add my q values, which is -2, and then I simplify it. So the lines of symmetry also shifted 1 unit to the left and 2 units down. 1 unit to the left and 2 units down. Let us look at the x and y intercepts. We get our x-intercept where y is equal to 0. To solve that, I must write everything on the same denominator. So I will have 1 minus 2 times x plus 1. That will be 1 minus 2x minus 2. And that I can simplify to minus 2x minus 1 over x plus 1. So y will be equal to 0 if this minus 2x minus 1 is equal to 0. But it can only happen when the numerator is equal to 0. The denominator has nothing to do with the function becoming 0. So in this case my x will be -1/2. My y-intercept in this case will happen when x is equal to 0. So if I substitute here in the place of x0, then I will get this value, so my y value will be -1. I can also do the vertices. I have my function. This is my function given by this equation 1 over x plus 1 minus 2. And my lines of symmetry, I have two of them, but because I have a plus sign here, I know I will be in my first and third quadrant. So I will use this line of symmetry and not y equal to minus x plus 1 minus 2. So it will not cut that line. So now I must solve 1 over x plus 1 minus 2 equal to x plus 1 minus 2. And we see we can ignore the minus 2 there, so we can just solve x plus 1 squared equal to 1. So x plus 1 is equal to plus or minus 1. So which is then x equal to 0 or x equal to minus 2. If x is 0, then y is equal to, we can put it in the line of symmetry or into the function, but it's quicker there. So I will have 0 plus 1 minus 2, which is minus 1. And if x is equal to minus 2, then y is equal to minus 2 plus 1 minus 2, which is equal to minus 3. So I have two coordinates. One is m, which happens at 0, minus 1, and the other one is g, that happens at minus 2, minus 3. So let us look at all this information and check it on our graph. I've just transferred my x-intercept there and my y-intercept and my two vertices. So when we look here on the graph, we saw that point A first moved 1 unit to the left, and then it moved 2 units down. So it's 1 unit to the left and 2 units down. The same with this point. 1 unit to the left and 2 units down. And if I look at my horizontal asymptote here, this is the line x equal to -1, and my horizontal asymptote is y equal to -2. And you can see here the distance between moved 1 to the left and 2 down to get to another point there, and for the other one you'll get exactly the same situation, but there's too much going on here. So my vertices here was A and B, but the vertices also shifted to the new position. 1 left, 2 down. Other vertex, 1 left, 2 down. And with my vertical and horizontal asymptote, which is in blue here.